Do you have an email, Adam? Adam at?
Thank you very much, Lev. The rest of the time we're going to do an introduction to C. Like I mentioned to you before, C will be used in Lab 2. And then all semester we're going to do what we call this side-by-side development, where on one side of the screen we're going to write in assembly, and the other side of the screen we're going to write it in C. Okay? If you recall from last week, we've been talking about I/O. We talked about direction registers. That's not the right key. Okay, click on that one. Pen. We talked about registers. We talked about accessing memory. We called functions in assembly language. Now we're going to do them in C. I mentioned what a variable was. What's a variable? Okay, a variable, right answer. The variable contains values, okay? Contains values. And we saw two types of variables so far. What were they? Globals and locals. And a global variable exists where? Everywhere. Not every time. It exists everywhere, right? Everywhere, every time. Permanent. And where does the local exist? Okay, the local variable is reduced in what we call scope. Well, who can access it? And when we did in assembly language, how did we implement local variables? In assembly language, we created a temporary variable. How? We wanted a number, we wanted a temporary... No, that's C. We're going to use int and C to make...
like whatever label.
No. That's I'm asking a very simple question. I'll ask it again. You want to? I don't want to. I want a very simple answer. I need a counter. It goes from 1 to 10. Temporarily, where would you put it? A register. Okay, so we've seen registers. Okay, I told you it was a simple question. All right, and now what we're going to do is we're going to add more features, both in C. We're going to do C today. We'll do these again in assembly language later. How do we create functions? How do we pass parameters? How do we create arrays? And that is where we're going. Okay, so we talked about variables, and variables contain data. And you remember that space pseudo-op in assembly language, what did it do? What went on this side right here? What did I put right here? Right where I wrote the word my. A label. That's the name of my variable. Okay? I started out calling it data. That was a stupid name. My is even equally stupid. Okay? And then what goes on the other side of space? A number. Like what? 2 or 4. Oops, back. What if I want an 8-bit variable? 1. It's not the number of bits, it's the number of bytes. Okay? And in assembly language, when I want to access a global variable, that's how I created it. I use LDR to read it and STR to store it. And as you saw from reading the book, if I want to access a 16-bit variable, I'm going to use an H. And if it's a signed 16-bit number, I'm going to use an SH. Okay, so unsigned, signed. And then if it's an 8-bit variable, there's going to be a B in there. This stands for half word. That stands for byte. If it's a signed 8-bit number, it's SB. And if it's unsigned 8-bit, it's a B. And then when I store, it'll be a B. So, okay, question, go.
Is that C on the left and assembly on the right?
Yes.
And then
yes. So the question was, all this stuff I've just talked about is assembly. These are all assembly instructions here.
And then this doesn't matter whether you're talking about a global or a local variable. Either way, it'll still be like...
Okay, so it does matter. He said, "Is it matter whether it's global or local?" On the left side, on the right side here in assembly, it matters because I don't have to load and store local variables. They're already in the registers. So I use load and store for the globals, and I'll use these instructions for the globals. Now on the other side, the left side, this is the C side, we're going to do the same sort of thing. We're going to decide whether we want 16, 32, or 8-bit variables, whether they want to be signed or unsigned, or their characters. And now this won't matter whether it's global or local over here. This will work for both globals and locals. Does it answer your question? Yeah. All right. I mentioned... Go.
Is there no STR/SH? That exists?
Okay, the reason why there's no SH is because when I load a little number into a big register, right, a 16-bit into a 32-bit, the question becomes, what do I do with the extra bits? Okay, I'm either going to sign extend it if it's SH, or zero pad it if it's H. And the same thing with 8 to 32. I'm going to either sign extend it or I'm going to zero pad it. This is a zero pad, that's a sign extend. But when I go store, I'm going from a big number, a 32-bit number. When I do a store, I take a 32-bit register and I'm going to store it into a 16-bit memory location. I got to throw away the top bits, regardless of whether it's signed or unsigned. So I don't have a separate instruction for signed and unsigned when I store. Yeah, practice. It's fun. Yeah.
So H means it's for 16-bit and B.
Yeah. H stands for half word,
Oh, okay.
and half word is a 16-bit thing. Good question. She said, "What's the H stand for?" Half word.
So that's why none of the stores have signed extension or not.
Yeah, because it's not when you do a store, you don't. He said there's no sign extension when you store, and that's because it's actually it's not a extension. It's a demotion. It's a reduction in bits. To go from 32 down to 16, I have to toss out the top 16 bits regardless of whether it's signed or unsigned. Which means it might have an error. Question? All right.
Wait,
Yeah.
actually, can you explain that? Like, when
Okay, so if I give me let me do 8-bit numbers because they're easy on my head. Okay, if I have an 8-bit variable and I store the number 100 in there, quick, someone tell me the hex for it. 100 decimal is what in hex?
64.
64. You guys are awesome. If you can't do that real fast, don't be intimidated. Anyway, that's the number 100. Okay. When I load it, okay, when I do an assuming it's unsigned, right? When I do an LDRB, that 64 is bumped up to 00000064, right? When I do an LDRB. But now if I add register whatever to itself, and now I have 200, right? I have 200 in register, right? Somebody tell me what 200 is? No, 200, right? I just want to multiply 64 times 2, right? No, 6. Yeah, okay, fine. I've got to do 400. Yeah, 6, 12, C8. I got to go bigger. All right, let's multiply it again. That's okay. Let me just pick a bigger number. 200. I'll multiply it again, and now I'm going to get 1. I multiply times 2. I multiply times 2 again, and I have a 181, 191, 190. There we go. 400. See? Yeah, sure. Right? So I have the hexadecimal 0x00000190 in the register, and I do an STRB. What happens? Right? I'm going to chunk out the 1 and store that into the memory. So whenever you store, you're demoting back to the smaller value. Your job to make sure that don't happen. Yeah.
So the U for C means it's unsigned?
Yes, great question. You said, look at all the, how do I tell in C whether it's signed or unsigned? Somebody answer her. U stands for unsigned and no U stands for signed.
Why does it matter for 32?
Oh, because she had, it's a wonderful question. On the Cortex-M, where there are 32-bit registers, it actually doesn't matter. But on your 64-bit laptop or your 128-bit program that you're going to create when you grow up, it'll matter. So in C, since they don't know the architecture, you will decide whether to call it signed or unsigned. And it actually matters, even if it's 32 bits, and we'll get there.
Yes.
But right now, it's your job to know whether it's signed or unsigned. It's your job to know whether it's 16, 32, or 8. And char stands for characters, letters, and symbols.
Aren't the actual type names for C like unsigned?
Fine.
and
Yeah, fine.
Signed in.
All right, fine. You want to call
short?
this C99? I'll call it C99. He said there are many, many names and many, many languages, and as you already heard, it don't matter. We're using C99. C99 is a more standard. It's easier to teach than short, long, and char. We're going to do C99. Those are the ones we're going to do. And I sprinkled in some old stuff that I forget to change.
So I guess when would you need to use care? Or
We're going to use char for characters, like the your initials, a J and then a V. Or how do I store the letter J? I want to store it in a character variable because it's a character.
Oh, okay.
Yeah.
So identified as this is
As a character, yeah. And it's a 7-bit ASCII character. Yeah. Question.
So only ASCII goes in characters?
Oh, if you're, he said, only ASCII goes into characters. I don't know. There's never, only is too strong a word. If you're writing good code, typically you'll put ASCII into characters. That's the right thing, but it's actually, it turns out it's exactly the same thing as this, by the way. So you could put -100 in there and it would still work. Just would be bad code. Yeah.
What does it mean when you say global is capital and local?
Okay, so don't you hate to be told which side of the road to drive on? And don't you? The question is, what's the cap? Rules are terrible. You got to eat 3 meals a day, and you got to pay your bills, and you got to tuck in your shirt, and you got to wear a tie to Expo, and the rules are just horrible. Can't grow a beard. There's a lot of rules about writing software, and I don't want to talk about those rules today, except that rules. If people didn't drive on the correct side of the road, we'd have chaos. It would sort of be fun for a while, but yeah. I'm going to use a programming style in the book and in class that sort of does weird stuff, just because I want to. I'm going to drive on the right side of the road just because it's be nicer if everyone drove on the right side. Every global variable I have is going to be capitalized. And every local variable I have is going to have a lowercase start with. Yeah.
Right, so just to clarify on the assembly side of things, LDRH would zero extend whatever value you put into it.
Oh, yeah.
LDRSH would sign extend.
Yes, absolutely. And the same thing with LDR. He said LDRH takes a 16-bit memory chunk, adds 16 zeros to create a 32-bit number and puts that in the register. Yeah.
Isn't the memory 8-bit?
But as he said, isn't the memory 8 bits? Absolutely. But how do I read? And let me ask you a question that you already know the answer to. Back when you did an LDR, what did you get? You got an address, and when you fetched from that address, what did you get? You filled up a register with what? How much data? When you did a LDR, when you read from whatever with an LDR, you fill up the entire register, which is how big? 32. And how do I read 32 bits from an 8-bit memory? 4 of them in Little Indian format. So how do I read? How do I read LDRH? With 2. I'm going to read 2 2 memory locations, chunk them together, little Indian style, and 0 pad the other 4, or sign extend for that one. Did that answer your question?
Access variables of different sizes.
Oh yeah, that's the whole point. He said, I'm accessing variables of different size. Yeah, welcome to the complicated big boy world, right? Big girl world. Yeah. And it gets more complicated than this, but yeah, it's your job to know whether it's 8, 16, or 32, whether you're writing in C, or Java, or whatever, Python, or whether you're writing in assembly language. But they're not two different things. When you access an int 16 variable, what opcode do you suppose it's using? LDR-SH. That's how it works. That's why we do them both. Okay, we talked about local variables having scope. In other words, where do they, when do they exist? And someone correctly said everywhere, that's right. Or within some small spot or local. And then where do they physically exist, either in memory as globals or in registers as locals.
And for C, does the label go, I forget.
No, we'll get there. Okay, in C, we're gonna, it goes after, but we'll get there. All right. We're going to, types matter. Types matter when you do an assignment. So when we take a value and we assign it into a variable, we're going to create a value, a number of a certain type, and we're going to store that type into this variable of the same type. Okay? You don't want to store minus 100 into an unsigned variable. That don't make sense. Okay? That's a mistake. The same thing when we add and subtract and multiply, divide, and take modulus. We're going to, by and large, operate on the same type. So we're going to decide on a type for our equation, and we're going to perform that same operation. We can, arithmetic operation obviously takes two numbers and gives us another number. Number, operate number plus number. Okay, takes a number, it takes another number, and gives us a number. Okay. Logical operations also take numbers. And give us another number. Then there we got the and the or, and the exclusive or, and the complement, and the right shift, and the left shift. Those are all logical operations. They take a 32-bit number, and they operate on another 32-bit number to give you another 32-bit number, and typically in a bitwise fashion for these. Okay? Each bit at a time. On the other hand, we have another thing that's not numbers. We have things called Booleans, and Boolean is a true or a false. And false being 0 and true being any number not 0. So a true false is Boolean. Oh, my favorite thing is fuzzy logic. With fuzzy logic, you can have maybe. Oh, here's another one. In the security world, there's another classification of Boolean: true, false, and unsecure. You don't believe it. There's a number in the computer, but it might be bad. And so we're going to start with the simple stuff, but it'll be fun for you to blow your mind and think about things that aren't true and false. But we're going to deal with true and false this semester. So a relational operation is going to take two numbers and operate on it to give you a Boolean. Right, obviously is A greater than 10. It's going to take the number, going to take the value out of variable A, the number 10, and tell you which is bigger, A or 10, and give you a true if it's bigger. I don't ever remember the precedence. The precedence is if you have a whole bunch of operations in the same row. There's a rule about which one you do first. I don't know what it is, and so what I usually do is add, I am what's called a parentheses zealot. A zealot is a crazy person, and I put in so many parentheses that I know exactly what it's doing just to make sure it does what I want it to do. Okay? But nevertheless, don't expect your lab partner to know what the precedence is, which one happens first, especially as you do this. This one is probably not what you expect to be. This one here you're going to get wrong. Come on. Am I erasing? No. A plus B shifted once. Okay, we'll come back here. B. All right. That's gone. And this is a divide by 2. What do you suppose this is? You won't have, how many think it's this? Sidebar, there's a third option. You have no idea which one it is. Okay? There's a third choice. How many thinks it's this? How many thinks it's this? How many don't know? Yeah. One person got it right. It's this. Yeah, isn't it stupid? Nobody knows what precedent is. You can either look it up or add your parentheses. Because, yeah, fine. Yeah, don't guess. Don't guess. Look it up. Yeah.
If you try to store a Boolean value into a variable,
Sure.
is it a runtime?
No. No, you can store Booleans into a variable because it then becomes a Boolean variable.
So you don't have to specify the type of the variable?
No, well, you know, any of the types can be Boolean, right? Because it can store 0 and not zeros. There are some, he said, can I store Booleans into variables that used to have numbers in it? Yeah. Normally you'd have a Boolean variable, and you'd always store Boolean stuff in the Boolean variable, but variables are just numbers. I mean, Booleans are just numbers, 0 and not 0. All right, let's go on. All right, so we saw the list of variable types. If you're going to make a global variable, it's going to look like this right here. This is an example of a global variable. You give it the type, you put a space, then you give it the name, and you put a semicolon, and that shows up in RAM, okay, with the name height. And you notice I made it capital H? Ooh, did you notice that? That's my rule about globals, capital H. And then I can operate on it. So, for instance, if I wanna do something or something else, I can use the if statement. The if statement takes inside the if, it's going to take a Boolean. So A greater than M, we're assuming A and M are the same variables of the same type. And if A is greater than M, it executes this. And if it's A is less than or equal to, it skips it altogether. This is an example of a convert uppercase to lowercase. So this is going to be a char variable. And if that char variable is greater than equal to A and less than or equal to Z, then I'm going to subtract off the difference between A and add the difference between A and C, converting lowercase to uppercase. You can have an else. So if this is if A is greater than B, and this is if A is less than or equal to B. So this is the true, and that's the false part. Question about if. Notice all my stuff ends in a semicolon. I use the brace to open up a segment. So if I want to execute a whole bunch of stuff like I equals 0, where there is some I have some variable I, and I can do two things inside the loop. This brace aligns with that brace. Okay, so I can do both of those things. So I'm a zealot for what? Parentheses. I'm also a zealot for braces. And so I always put a brace in there just to make sure it's very clear in my mind that the beginning of this if statement begins with that brace, the end of that if statement ends in that brace, and I'm done. The int main void business, that's a weird stuff. That's just the name of my C program. Yeah.
Do you do else ifs, or do you just like nest the ifs inside the
I can do all sorts of things. Can I put, he said, can I do weird stuff? Absolutely. Yes, but not in the next couple of weeks. I won't need it. Yeah, what, go?
You have to say A or B at the very least before.
Yeah, sure. Yeah, you're totally right. This is a single pass compiler. Somewhere up here above was going to be something like uint 32 underline T A and M. Sometime before I get there, I'm going to have to set A equal to something and M equal to something. All right, so I'm going to create a variable, either local or global. I'm going to fill them up, and then I'm going to execute this code. Yeah, good question.
So letter, when it says letter is greater than or equal to character A, does it refer to the ASCII value?
Yeah, that quote A quote is, okay, so let's see, we got weird people who know what the number 100 is in hex. Anybody know what the letter A is in hex? No? Oh. It's not hex 65. Yeah, you're almost, he's half weird. It's decimal 65, by the way.
Oh.
41.
Oh, yeah.
Yeah, so he's memorized his ASCII table. He's a weird one. Don't have to memorize the ASCII table. You just use quote A quote, and then it'll get you the right 64. Yeah.
You get ASCII values for increase add.
They do. Yeah. That's how that worked. I didn't have to do each one separately. Until you get the stupid Unicode,
Add 32.
and then it gets weird, but this is ASCII. Yeah. Question.
That's how it is.
Shh. What? Go ahead. You have to speak up.
Oh, I was going to say, if and the loop is one where basically the first segment string you go to the second segment. I mean, let's say the first segment is false, does it mean you skip the second segment?
Okay, so you talk about this one or that one? First, the first one here.
Yeah, and this one fails, let's say.
You said, okay, if you have Justin, he said, what happens if, if it's true or if it's false? Okay? With an if, you're going to execute this stuff between that brace and this brace if it's true. If it's false, you're going to skip that, and in both cases, you're going to end up here. So, whereas in the if, with the else, you execute this part there if it's what? True. Because there's only two choices, it's either true or not true. Okay? If it's false, you're going to execute that, and in both cases, you end up here. Did I answer your question?
Okay, so let's say it is false.
If it's false, you execute this.
I don't know, I understand the defender side. I'm still wondering about the defender. Let's say, so basically we go one step at a time for the defender. So even if it's true or false, we'll go to the second step, basically.
No. So this is going to happen, this one happens first. Right? I'm going to compare A to M. If it's true, I'm going to execute this. If it's false, I'm not going to execute that. So if you think about 1, 2, 3, I always execute 1, I always execute 3, and 2, I'm either going to do if it's true, and I'm not going to do if it's false. Think of this in flowchart form. All right, when I compare A to M, how many choices do I got? 2. What are they? Is A greater than M, or is A less than or equal to M? If A is less than or equal to M, I do absolutely nothing. If A is greater than M, I'm going to execute this one. And then end up back here.
No, I meant but
That looks like
once,
a stick.
once we do the first part of it, it says if A is greater than, and let's say it's false. Do we then do the if whether it's greater than equal to right?
Oh, yeah, sure. And I confused you. All right. These are two separate, completely unrelated efforts. Which, what I would execute the second if, regardless of whether the first if was done. Because in C, it executes from top to bottom until you hit a whatever function. Whatever. Good question.
That clue is the unsigned of the 16, like on the very right.
I-
What's the
Slow. This one here.
Yeah.
All right. So, what's the purpose? Okay, just to teach you if. You said, what's the purpose of this? I could say that this is the height of your ball bouncing, and if it goes under the floor so far, it's going to come back up to the. There's no purpose. I mean, this tells you if height happens to be illegal, right? Let's say height was supposed to be any number between -5 and +5. And if it goes too low, it will then reset back to start. Like Candyland, go back to slide down the slide and you end up in the... there's no purpose. Let's make a purpose, all right? And as a matter of fact, let's do a purpose. I like that. I like you. Yeah, one more question on this slide.
And then, just a question, letter is a local variable, correct?
Yeah, just like, yeah. And what type is letter? No, yeah, what type is it? Char. So somewhere, either local or global, I'm going to have to put in char. Yeah, you're totally right. I shouldn't.
And do things like each of the if then else, is that like just gibberish right now, or?
Yeah, it's totally, it's gibberish in a sense. This one here actually does something. This one here takes a ASCII letter, which is anything you can think of, A, Z, X, plus, space, and if it happens to be a capital letter, it converts it to the equivalent lowercase letter.
Oh, so that's what that.
That's what that actually does.
Okay, I was just confused with.
Yeah, I don't care. Can I say I don't care?
Yeah.
All right. Let's do some C. Let me switch gears here. Come on, stop.
Professor,
Yeah. Oh, wait, hold on. Go.
on that slide, do you need that void?
Okay. Don't get legal on me. He said, "Do I need the void there or not?" It all depends on which compiler you're using. Our compiler will take either. You can either leave the void or put the void in. Can I say I don't care? For the same thing with the int. Those are not used in this embedded system, so it doesn't really matter. For example, here I left the void in. I could take the void out and it wouldn't matter. Just void right here doesn't matter. All right. Great question. Let's talk about the components of a C program. As you know, it's written in .c. What was in .startup? You remember? Have you ever you've been using .startup. In there, it tells you where to start. Okay? And in your assembly language, where did it start? Start. And in C, it starts in main. Yeah, fine. That's just the way. Okay. So at the very top are some things that we're going to do. Lev called them breadcrumbs. Like a year from now, I'm going to look at this code and go, "What in crap is this code for?" And I'm going to read these comments and go, "Oh, it's a NOT gate." That's what it is. That's what the comments say. Okay, fair enough. It's a NOT gate, but what are my inputs? I don't know. I don't remember. Well, I'm going to read it. It's going to say PE1 is the output to the LED, and PE0 was the input from the switch, both in positive logic. Now I can build it, right? And okay, fine. That's my input. So what does it do? Okay, when you push the switch, the light goes off. When you let go of the switch, the light goes on. Right? Not as complicated as Skylark, but kind of fun, and it's really fun. Remember, I will pat it around. What's going to happen when you push the button? What does the comment say? It goes off. Okay, so there's the button. Push it. See what happens. All right. Doesn't blink, but push the button, pass it on. The wire falls out. I don't care.
So
All right.
do we edit in startup or not?
No, don't edit startup. Look at it, but don't edit it. All right. So, as you know, okay. What's the next part? Is a bunch of in C we'll have these includes. Throughout this semester, we're always going to include standard.int. That means we're going to be able to, in standard.int, it's going to define that all those variable types we just had on the slide. uint 32, uint 16, int 32, int 16. Those types are defined in the standard ints in here so that we can use them. This one, as you might imagine from the names, does that look familiar, those letters? That's your processor, that's your TM4C Cortex-M. So in there are all the port definitions. You don't have to memorize where the ports are. Right? I'll come back to init-f in a moment. Let's go down here to main. And there you go, I violated my rule already, so I'll fix it. I said we use C99, I meant it. I got two global variables, in and out. Where do they exist? Everywhere. They're in RAM, and anybody can access them. Okay? Yeah, go.
So are they global because of where you place?
Oh, yeah. Yeah, like, yeah, you said they're global. How did I tell them they were global? I can make them local if you want. Now they're local. So, where they, if it's inside a brace, it's local. And that means where is it? Yeah, but where's it going to be when it runs? In registers. It might end up on the stack, but it's in registers. Okay? And if I put it there, it goes in global memory in RAM and exists forever. Okay? Cool.
So what did startup.s do again? That told the assembler for the program.
Okay, so there's a couple of things in startup.s that are interesting to you. He said, "What's in startup.s?" Let me ask you another question. What's a stack? What is a stack? Okay, so he said a stack is a great answer. A stack is a bunch of memory locations that you put temporary crap in, right? And to two operations on the stack are what? Push and pop. And now I ask him, okay, man, where is it? Because that's your job. You got to know everything. Or how much stuff do you got? Well, here's your answer. Okay, your stack is exactly 1,024 bytes big. And there it is, with another area that you don't have to know, but there it is. That's how big it is. That's your space. You remember what space does? What does space do? Allocate space in RAM. That's actually where your stack showed up. Yeah.
So can you make the stack bigger?
Oh yeah, yeah. That's plenty big enough for you, but she's got needs. I can't make it 100 million. Why? You only got 32 kilobytes of RAM. You don't got those Texas memory systems with. How big were your memories, Lev? How big were your memories when you did your memory thing at Texas Memory Systems? Terabytes? Okay, these folks have. Yeah, these see that, and we have kilobytes, 32 of them. Yeah, good. That was a good question. The other thing is, where does it start? When you hit the reset button, it turns out that the location that you start in is called the vector table, and there it is, location 4 in ROM. Location 4 in ROM is where it starts when you hit the reset button. And it will eventually call main. Those are the two things that you got to know from startup. How big your stack is and where does it actually start. We will talk about all this fun stuff. Now, you did some of this in 306 and BME 303. Where have you heard the word handler before? The word handler? Interrupts. And, you know, big boy, big girl world, there's over 200 of these interrupts. There's a lot. We'll do just a few. All right. All right, so
So I forget, the include STD is basically the equivalent of like assembly start, right?
no. Include what? This is
The
just
one above.
this one just this include means define the C99 variables. That's all it is. This is define the I/O ports. There's nothing here. There's no magic. It's all here. Okay. What does an assignment do in C? Two sides on the right-hand side is what? A data, a value. And on the left-hand side is what? A variable or a location. In this context, that location, as you know from the last week, is the clock register for the ports. Okay? So it takes a value and stores it in the clock register. In C, if you put a variable on the other side of the equal sign, what do you get? When it evaluates the right-hand side of this thing, when I put a variable in there, what do I get? The value of that variable. So I'm going to take the existing value of the clock register, or it with a 20, and store it back in the clock register. Which, as you know, did what? Look at big picture, little picture. From a little picture standpoint, I set bit 5, right? But from a big picture standpoint, what did I do? Turn on the clock. Yeah, and that's port F. Okay. All right. So let me go down and do. Yeah, let me go down and do port E again. Sorry, I'm going to do this one. That was port F. I'm going to do port E. I'm turn on port E. Okay. And after we turned it on, what did I have to do? I had to do a delay. And so in this compiler, what I'm going to do is I'm going to take a local variable, I'm going to store a number into there, and I'm going to say, hey, compiler, don't optimize it, don't throw it out. And so I made it volatile. So I made a local variable called delay. I stored some stupid value in there just to waste a couple of seconds. Okay. All right, but I'm a lazy typer. Okay, this operation here is something I do a lot, and so I'm going to replace it with this one. These two are identical. I don't need to do them both, so I'll get rid of that one. Line 29 and line 30 are exactly the same code. They're just less typing. Okay, with me? Yeah.
What is the lock?
He said, what's the lock? Can I say, I don't care. Because you have to, port F, bit 0 is locked. And you have to unlock it. Either in C and in assembly. So once we start using port F bit 0, you're going to have to unlock it. Port D bit 7 also has to be unlocked. I want you to understand this line of code here in C. Okay? All right, so now I'm going to go down and do the rest of the stuff that you already know. And again, this is the same line as this one, is I read port E, I OR it with 20, and I store it back. Okay. That sets the.
So the vertical line basically.
That's vertical line's an OR, and is let me do this one. All right, what is the twiggle? That's the not. So if I were to break this down by step, what would 0x10 not be? If I take all the bits and I invert them, what do I get? 1, 2, 3, 4, 5, 6, 7 F? Something like that? Did I get enough Fs?
No.
Oh yeah, F. It's not there. It's E. There we go. Yeah, there we go. Right, all the bits, but that one.
That one's the ones place, not the 16s place.
But that's not. This is bit 4.
Oh, that one.
That one's bit 4, right there. You see it right there, bit 4. Oh yeah, no, you're totally right. Yeah, I do fine. Yeah. Thank you. You're smart. You're smart. I made a mistake. Thank you. Okay. All right. Let me. And then the middle of my code is I'm going to read the variable, and read the input. I masked it with 1, just like I did in the assembly language version. I inverted it, I shifted it, and I output it. Okay. So let me summarize what you learned in C. How do I create a variable? Type, name. How do I create 2 variables? Type, name, comma, name. Okay. What does the equal sign do? Assigns. It calculates a value on this side of the equal sign and assigns it into there. Every line in C ends with what? Semicolon. That's how it knows one thing. The while loop is the thing that occurs over and over again. We saw if, and we saw if then as a way for you to also solve this problem. Could you have solved this problem with if and then else? I'll give you that as a thought exercise. Solve the not problem with an if. This code here you have on your computer already. This is not, right? This is the not gate project. Try to solve this with the if, then, else code. All right. So we're learning C. We're going to do loops and arrays and stuff next time. Go ahead and read this portion of the book. Ask lots of questions. Thank you very much. Good luck if you're going to Expo.
Hi, Mac. Well, I have one.
So you would only set 2.